Okay, folks, I don't think Kief needs an introduction, but I'll try my best. We'll welcome Kief for our closing note. Kief is an highly respected and accomplished professional in the field of cloud and infrastructure technologies. He has more than 15 years of experience, and he's also a frequent speaker at industry conferences, events, and he's very well known for his book, Infrastructure as Code, Managing Servers in the Cloud. And this book actually is, and how do I say, a widely accepted reference material for IT professionals. So please join me in welcoming Kief as he concludes our conference with his closing note. Over to you, Kief.
Thanks a lot, and thanks for having me. It's really good to be here. Right, so what I'm going to talk about today is modernizing cloud infrastructure. Obviously, my particular interest is at the level of infrastructure as code. But I think it's really important to think about and understand how the infrastructure code at that level, how it affects everything above it up to the kind of organizational goals. So I'll talk about that a little bit. But I want to talk about the industry trends of cloud, right? So I used to talk about going from the iron age of IT to the cloud age of IT. So the iron age being when everything was in data centers, everything was physical machines, and we managed them manually. So changes were slow and very expensive. And so if you made a mistake, it was an expensive mistake. It took a long time to correct. And so the way that we managed risk in those days is by making changes more difficult, basically. I'm being very kind of, I guess, funny in saying it that way. But, you know, we put barriers in, we make sure there's lots of process, and we make it very slow. Interestingly, research shows that these heavyweight change processes, and here we're talking about things like waterfall and related types of processes, actually didn't make things more reliable. So having all of that extra process around changes doesn't tend to improve system reliability in the long term, but it seemed like a sensible way to approach things. And I talk about this like it's in the past, but in the reality, of course, the future is not evenly distributed. So many organizations are still working, still in the data center, often still in using mainframes, and even still using these kinds of processes. So this is still with us. Now, the dream of the cloud age is that we have this cloud services with APIs. We have automation like infrastructure as code. That means that changes can be done very quickly and very easily. And so how do we manage change? We do it by shrinking the feedback loop. And this is the idea behind things like Agile, like DevOps, like all of these processes are ways to have, how do you bring things closer together, make smaller changes, use automated testing so that we find out if things are wrong very quickly. So, you know, how do we make the feedback loop very, very quick so that we can make our delivery very, very quick? What I've realized thinking about it recently is that it's not just those two phases. We kind of have a process that we've been following as an industry to get to that cloud age. And so I think probably a few years ago, we were in what I would call the age of shadows. And this is the time when the new technologies and even the new processes and ways of working they were just in startups, or they were in a digital part of the organization. So you might have a large enterprise organization that would set up a separate digital department that would do things very differently from the main part of the organization. So the idea was that we needed to adopt these new technologies and move very quickly. And in terms of managing risk, oftentimes the approach would be to ignore risk. We want to get rid of the old IT department that makes things go slow. We want to ignore them, do our own thing. We're going to move fast and break things. And I would say in the past few years, we've moved past that. So it's not just startups, and it's not just separate digital departments. Instead, we have, and even large enterprises, even in banks, are moving onto the cloud and adopting these technologies and realizing it's not something we can keep off to the side. And I'm calling this the age of sprawl. And so what I mean by this is that everybody is moving very quickly to adopt new technologies, adopt new platforms, get things onto the cloud. And as a result, things have gotten very messy. So like I said, the new technology has moved to the core, And we're tending to accumulate technical debt in many of these organizations. So, oftentimes we have these companies, these clients that we work for at ThoughtWorks, where it's, they have like 4 or 5 different teams who've built Kubernetes clusters. And so they're all very separate. They're doing similar things. And so all of this stuff is kind of accumulating and growing. And then new technology comes on. And so actually you now have legacy technology that's 4 or 5 years old. You didn't think it was legacy then, but it's become legacy now. So I think that we're now kind of on this cusp. We're kind of on this change where we need to get more mature about how we use cloud technologies. Obviously the global environment in terms of the economy is very difficult. People are looking now at costs and thinking, can we afford to have 4 or 5 different teams all running separate Kubernetes clusters? Or do we need to think about how to kind of manage things more effectively? And so basically the situation we're in is we can't afford to throw money at things to grow fast. I think before everybody wanted to get onto the new technology because they wanted to keep moving, grab opportunities that were out there, and not fall behind and be overtaken by other companies that were better at digital technology. Everybody needed to become good at digital technology, doing digital transformations. And so the speed was the most important thing. Now, we have to be more careful. But I don't think most organizations are thinking that we're going to stop moving. They might be looking at budgets and how to cut budgets and tighten budgets, but they're not saying that, well, we're going to stop innovating, we're going to stop moving forwards, and we're just going to kind of, cover our heads and wait for the economy to improve, because I think we know that things still move on, and other competitors will take opportunities and move. So it's not about stopping and cutting everything. It's about being smarter about how we're using money to get value. So it's about thinking about how to rationalize what we have in terms of infrastructure that we've built and how to kind of make it more clean and consolidated. So how do we get to this kind of cloud sprawl situation? Well, it's been growth, as I said, has been one of the main things. So if you think about a kind of example company that maybe had a store in the UK that was running in the data center, online store, and then they would do things like adopt new technology. So obviously things like moving to the cloud, they're going to decide they're going to use AWS, they're going to use CloudFormation, and then maybe they decide, oh, we need to adopt Kubernetes, and then they decide we need serverless, and so all of this kind of accumulates. And then also in many cases, they expand to new regions. And one of the things that we see companies doing when they're expanding to other regions in terms of their cloud and infrastructure as code is they copy the code. So they take the code that they've been using to run their UK store, and they copy it to a separate copy of infrastructure code to run their store in Germany. And then they maintain those separately and they customize them. And you end up with kind of these snowflakes, and everything becomes, multiple snowflakes that are different. And so each new region, in each new instance that we manage in this way means you have to add more people, and it takes more time. And so the cost goes up faster than you might like. And another thing that happens is people acquire businesses, right? So you have these acquisitions, then you have to work out how to integrate them. So in this example, this company buys another company that has stores in the UK and in the US, but they run on Google Cloud and they have different infrastructure. And so now you've got all these different infrastructure to manage. And then we build new products, right? So they decide we need to start up a department that's going to do some analysis of products and buying behaviors and so on, use machine learning. And so they decide they need to build a new data platform for that. And so this is kind of an example, a little bit of a made up example, but this is like many, people will recognize these kind of situations that happen, of how you end up with all this mess of different infrastructure and different tools and technology. And so this means it's difficult to apply governance to all of this with everything different, and to make sure that the quality is right and the compliance is right and all of that. Resource management is becoming difficult. And this is why we have things like a big focus on FinOps now and cloud economics. This thing of our cloud hosting costs are growing, and it's very difficult to manage them and to predict them and to control them. So that's more of a concern. And also I would put in things like green, carbon emissions and stuff. So people are paying attention to Where are we hosting? And even in terms of cloud, some cloud regions emit more carbon, depending on where their energy sources come from. And so one of the things about everything that's going on with people being more focused on zero emissions, moving towards lower emissions and these kinds of things, is how do we look at our cloud usage and think about ways to optimize that. And I mean, then still speed and time to market. When you have this kind of sprawl that I'm talking about and all these different things, it becomes slower and slower to enter new markets and introduce more products, new products, just because everything, all of the maintenance and everything that's involved, and again, the overhead of things like governance, all becomes worse and worse the more you have. And then there's just operational quality. So reliability of stability and performance for users, and security, and all of these kind of things are things which become harder and harder as you get larger and larger. So one of the reasons I think people have found themselves in this situation is because of this idea that, especially oftentimes among management, where if we're going to adopt cloud, we're getting AWS as our vendor, for example, that's our platform. And so we can just tell the developers, go and use it, and we don't need to worry about it. We don't need to think about platform. Well, Corey Quinn, who has a weekly newsletter on AWS that some of you may know about, he wrote an article a few years ago called 17 different ways that you can run a container on AWS. And this kind of shows that, like, even something as simple as saying, well, our developers can use Docker and run it on AWS, and we don't have to worry about platform. Well, actually, you can create a big mess with all the different options there are how to do things. And he followed up this article a little while later with 17 more ways to run containers on AWS. So I think this has a lot to do with why we're seeing platform engineering become a big topic in the past year or two. PaaS, platform as a service, was a topic some years ago, where people talked about this kind of platforms and building platforms for developers and so on. It's not talked about so much, and then it's kind of resurged under the label of platform engineering. And so why is this a thing now? And I think it has a lot to do with this picture, which many of you will have seen, which is the landscape from the Cloud Native Computing Foundation, CNCF, of all the kinds of tools and products and so on that are related to cloud native computing. And it's a lot of stuff, and it's a lot of stuff to manage. And so this is where, rather than just saying, well, developers can just use the cloud and not worry about anything, we have serverless, which means we don't have infrastructure. Well, you do have infrastructure. You have lots of things to worry about, actually. You have to choose which ones of these will we use. You have to integrate them and configure them and debug them and then maintain them and support them. And it's all constantly changing. So some of these will disappear, they go out of business, or some of them kind of become less fit for purpose. And new ones come up and you realize, okay, we need to kind of change to new options that are out there. And so it's a very constantly changing and moving and very complicated landscape of things to manage. And that's why I think it's become a big kind of meme in the industry these days that, well, we need to think about actually within any organization and product organization, do we need to have people who are managing this stuff for us because it's so complicated? I kind of believe that this is a transitional thing, that that landscape will consolidate. You'll have kind of vendors will consolidate. Some products or combinations of products will become dominant, basically, and more mature, so that they become easier to manage and easier to integrate and configure over time. So I think it's like in this picture of the early days of automobiles, when the early owners of automobiles, if you owned an automobile, you had to be pretty rich, not only to pay for the automobile, but you normally had to hire somebody full-time to work for you as your personal mechanic to keep the car running and keep it operating. And I think that's where we are with kind of infrastructure and cloud platforms and all of this, is that you have to have these platform engineering teams because everything is kind of primitive still. But I like to think that things will improve and modernize, and that won't be necessarily the case in the future. So in terms of, particularly of like clients that we see these days who are needing to make improvements to how they're managing that cloud infrastructure, how they're managing that sprawl, there are a few different drivers that I think are interesting to think about that affect how we manage infrastructure and how we do infrastructure as code. So one is just the still ongoing modernization. We have lots of legacy technology still that gets expensive and difficult to support, especially as skills are harder to find because those technologies become more legacy. And so, the question I think we need to ask is, how can we make sure that not only do we just adopt the latest technologies, so we don't just want to do modernization and digital transformation as a refresh. Let's get the latest technology right now, and then in a few years' time, it becomes legacy again. Instead, we need to think about how are we building and using and maintaining our infrastructure and our systems so that we can adopt and bring in new technologies as they come in and retire old technologies. So it's a kind of a continuous modernization rather than one-off projects. And then there's just improving operational quality. And this is always a thing where people have difficulties. They find that their systems are unstable and crashing a lot. And so they need to think about how to address that. Or maybe they need to be worried about security, about their systems, data, privacy and management, and those kinds of things. So operational quality is often a thing that people need to think about when looking at their infrastructure. And as I've touched on a couple of times, we have to support growth. We have to keep looking for new opportunities. We have to be able to enter in new markets, introduce new products, and to be able to do those without, ridiculously expanding our costs, right? So we don't want to double our costs or have a very linear growth in our costs as we enter new markets. We kind of want to be able to leverage things that we have in a smart way so that we can do these new things in a cost-conscious way. And then there's just consolidating that kind of sprawl that I mentioned. So those things where we've built lots of different platforms and technology stacks and we've acquired things and so on. How do we kind of bring them together so that we have less to manage and that's more consistent, the things that we need to manage? And then an ongoing thing, particularly for ThoughtWorks, we're well known for our software delivery expertise. And so, people come to us about the software delivery effectiveness. We need to, the 4 key metrics and that kind of thing. We need to be able to get our software and changes to our software deployed all the way into production more frequently, more reliably, and more quickly with shorter gaps, those kinds of things. And so the infrastructure has to support doing that. It has to be built in ways that support doing that. Oftentimes when we look at organizations, it's usually a combination of things. When people are having difficulty with delivering software really effectively, but infrastructure is often one of those things that has to change in order to support better ways of doing things. So there's I'll talk about 2 different approaches to platform strategy. In normal fashion, I'll say that the way that I don't think works as well, which is centralized platform strategy. And so this is where you have the idea that a central team or group of teams is going to provide infrastructure and everybody else must just use whatever they're given and use it in the way that they're given. And this centralized approach tends to create bottlenecks. And so when a product team needs to do something new, needs a new capability, or even needs to fix something, oftentimes they have to wait for the platform, a team or a support team or what have you to do it for them. And so that's disempowering to those teams, product teams and development teams, and even support teams, application support teams. It disempowers them because they see something goes wrong and they say, well, it's not something I can do anything about. I have to ask somebody else and wait. And so I don't have control. And so that's not really ideal. It also doesn't scale very well because when you start looking at that sprawl picture of all these we've had different stores in different countries and different products, having a single platform that supports all of them can be difficult and take a long time to build. They have different requirements, different things that they're doing. And so often what happens is it just takes a long time to build and it doesn't actually get finished. And those different teams don't end up using it. They use different things because they can't rely on the central team to manage it. and also keeping up with changes and everything. So having this really centralized view of how this works is not ideal. So what I would encourage people to think about is a more composable platform strategy. And this is the idea that rather than thinking about platform services being provided centrally necessarily, it's how can different parts of the organization, different teams, different groups build infrastructure and build services in ways that makes it easy to share. So firstly, we do that by defining standards for providing, consuming, and integrating services. So if you're going to build a service, let's say a Kubernetes cluster, or you're going to build an ELK stack for log aggregation and those kind of things, and analysis and observability. If you're going to provide that, how do you build it in such a way? What are the standards to make sure that it plugs in easily with other services being provided in the organization by other teams? So it's boundaries and contracts and APIs and all those kinds of things, but for infrastructure. And then thinking about those boundaries and designing them around domain concepts. So I think one of the traditional anti-patterns that we have with infrastructure and platforms is teams that are organized around technologies and even vendors. So you'll have like a Linux team and a Windows team and a Cisco team, an Oracle team. And instead of that, we need to think about the domain concept. So there's an identity team, there may be a data team, there may be a compute team, so on and so on. So thinking about what their outcomes they're enabling, and then designing the systems and the infrastructure and the boundaries around those concepts rather than technical ones. And then we need to provide what I call scaffolding for delivering changes. And so this is just basically, look, if people are going to write infrastructure as code, how do you package that infrastructure code? How do you test it? How do you make it available? How do you consume it? How do you deploy it, and so on? And so it's kind of standardizing on that and providing tools to make it easy for any team who is building infrastructure or platform services to do that and to deliver it and not have to reinvent the wheel with all of the kind of scripts and tools and things that most teams working on infrastructure end up writing for themselves. And then it's about encouraging people to extend, share, and add capabilities. So it's just the mentality and the philosophy around how people are providing services and infrastructure, just to do it in a way. This product thinking is probably a good way to put this, that we have to think about these as product thinking. And then if this is done well, we can support different team topologies. So you might have a central team that provides a particular platform service. Maybe the identity team runs a service for that and provides that. You might have other ways of organizing it, though, where, for example, a team that's doing machine learning or some other kind of specialty might provide a service and build some infrastructure that suits their purpose that other people don't necessarily need, or they can consume from them if they do need it. But it doesn't kind of restrict people and say, well, you're a product team, you're a development team, you're not allowed to touch infrastructure. It's like you can touch infrastructure if you follow, these standards and these ways of doing things. And so what it often comes down to, and how to kind of build this stuff out, is thinking about infrastructure as code, as with any software. It's thinking about good design principles. So Dan North, who's a former thought worker, has recently, in the past year or two, he's published some articles on his blog about what he calls Cupid, which is design properties of a system. And I find that they apply very nicely to infrastructure as code, as well as he's thinking about software design and software architecture, but I think it applies very well to infrastructure. So, and this is the idea of composable, which is obviously a favorite word of mine for infrastructure, just this idea that we should be able to make different pieces of infrastructure fit together and be replaceable and so on. The Unix philosophy of making small pieces that do one thing well. So, and I'll talk in a moment about some of the kind of ways of structuring infrastructure code. I'm very much a believer in making small pieces of infrastructure code and projects that have a limit to what they actually do to make it more composable. Predictable is just that, like, if you have a component that does a thing, that it does what you expect, it works the way that you expect. I think with simpler pieces that that becomes easier. By idiomatic, we mean that things are built in the way that the tooling kind of is designed to support. So you're not trying to bend and fit something to do things that it's not. So as an example, with infrastructure code, it's very common to take declarative infrastructure language like, say, Terraform or Ansible, things that are using YAML and so on, and to try to put programming constructs into that. So you have like conditionals and loops and so on in YAML, for instance, is something you see with say Ansible code. And so the idea is to avoid doing that. And I'm a big proponent of using different tools and the right tools for the job. So sometimes we have these new languages, things like CDK and Pulumi, where you can use a full programming language. And so using those kind of tools where that's what you need to do, but also separating it out and realizing it's not always useful to write programming code for things which shouldn't be procedural, that are more kind of configuration, because that's, I think, where things get ugly and messy. Anyways, and then domain-based I've talked about. So thinking about your components of your system, including your infrastructure, based on domain. So composable cloud infrastructure, the way that I like to approach kind of the architecture is kind of in two levels and two layers. This is something I've been thinking about fairly recently. And so the idea is that you think about those platform services as kind of bundles of infrastructure that are designed around domain concepts. And these are things that product teams, development teams can provision using platforms and portals. They can do self-service provisioning of these things. So these things should be designed from the point of view of the consumers, like those development teams and product teams. Like, what are the things that they care about? How do they think about the system underneath them, rather than necessarily the low-level details of how the infrastructure is actually provided. And so it's that kind of almost an abstraction layer. And then the infrastructure as code kind of underneath that. So you use infrastructure as code to build the platform services, or at least the infrastructure to deploy platform services, like, again, like Elk stacks, for example. You need to provision servers and storage and so on, that the Elk software can be deployed onto. And so to do that, I think there's another layer of the architecture where you think about the infrastructure stacks. And that's something that isn't necessarily as visible to developers, although they should be able to. Just as an aside, when we talk about abstraction layers and so on, I'm a big fan that it's not about hiding things from developers. It's not about disempowering them and saying you're not allowed to do things. Instead, it's just about allowing them to think about a certain context at a time, but still be able to switch context. So if you're using a platform service and then you're finding some issues with it, you're able to then look down beneath and see, okay, what is underneath it in terms of these infrastructure stacks that I'll talk about. And you're able to kind of get into that and debug and maybe even contribute changes to that. So for these infrastructure stacks, these lower level pieces of infrastructure code, we need to optimize these for change. So in terms of where do we draw the boundaries? So one way of deciding, so I'll give an example of, like, let's say we're building that Elk stack. And the Elk stack, it needs some storage, it needs some networking to kind of, so the traffic to come in. It needs some compute. Maybe you're running things in Kubernetes containers, or maybe you're running them on server instances. So anyways, you think about all those different pieces of infrastructure that you need to support your Elk stack. And you think about how often do the different pieces change? So maybe you're changing, if you're running on servers, maybe you change those servers very frequently, because every time you have a new version of the software that runs on them, you build a new server. Maybe you're doing immutable servers. And so you'll change those servers very frequently. Whereas the networking, you might not change as frequently. And maybe it takes a long time, right? A lot of times when you have things like load balancers and so on, and DNS entries, when you make a change to it, it's very slow. And so it might be nice to separate that out and say, I can change my servers more quickly because I need to change them more often. And I can optimize the time for the change by not having to also wait for changes to DNS and so on, if I split those apart. There's also data persistence strategies. So the data that where you're storing for your Elk stack, the log data and indexes and everything like that, that takes a long time to kind of deal with. If you're going to destroy it, you need to back up that data first, and then rebuild the infrastructure, and then reload the data onto it. So that's it's slower and more difficult. And also you need to worry about retention and backups and so on, that you might not need to worry about for your servers and for your networking and so on. And so you might actually have a different process, a life cycle for those parts of the infrastructure. And so you can separate them into different stacks. And just to be clear, I realized I haven't explicitly said this. When I'm talking about stacks, I'm not talking about modules or libraries. I'm talking about projects, things that align with state files, because you can deploy them separately. You can make a change to them separately without changing the other pieces. And so this is why it's more like microservices than libraries, separately deployable pieces of infrastructure. And so then another reason to change to decide where to draw the boundaries for these pieces are about things like risk and governance, compliance, and those kind of things. So if you have some parts of your system that are hosting personal user data that needs to be treated differently with different legal obligations, or things that are dealing with, say, transactions, credit card numbers, and so on, you probably want to separate those out so that you can apply more rigorous, testing and auditing and so on, that you don't necessarily need to apply to other parts of your infrastructure that aren't subject to those regulations. And then finally, team ownership. And this comes back to Conway's law. So if you have a team that, for instance, is responsible for networking, they might build and provide the infrastructure code that creates networking structures that another team can then use and deploy by adding other stacks to it. But the stack boundary makes a nice place, so that rather than saying, if you have an infrastructure project and there's multiple teams that work on that infrastructure code, or might need to make changes to it, or might need to ask for changes to it, that creates friction. And so you can think about, well, are there a different way we can split our infrastructure code so that we don't have those kind of cross-team coordination that we need to do so much. And you can put that coordination into the boundaries, into contracts and APIs between your things. And so this way we can keep these stacks loosely coupled, just like you do with any software, so that we can change them separately. So you want to make sure, again, each stack is separately deployable. So you don't need to worry about, again, with modules, if all of this was in modules, you might need to worry about, you're going to apply it, you make a change to your module, and then to apply it, it needs to kind of be coordinated with what's going on with the other modules in that, in the stack. So you define the interfaces for the inputs and outputs of the stack and separate them out. And this is important, and we need to separate them from the resource implementations. So a lot of time with infrastructure code, you'll see that people handle the dependencies between them by having looking up things, or knowing that another stack or another Terraform project, for example, has created something. And so, the code looks that up, and that creates a tight coupling. And we've learned over the decades, really, not to do that with software, not to have, for instance, software that knows about the database structures and schema of another application and then integrates with those, because then it becomes difficult to make changes to one of those applications without breaking the other. And so we need to do the same thing with infrastructure. So we use pipelines then. For those stack packages, we use a pipeline just like we do for software code, and it runs automated tests against the project. So we package it up, we put a version number on it, we run tests, and we promote that package across. And then we combine them together into those services. So when we have a service like our Elk stack, we take the packages that came from, and maybe different teams provided some of the infrastructure. Like I said, a network team provided a stack for the networking, and then we have a storage stack that maybe is a standard stack that allocates storage that we can use, a database or what have you. And so we put those together, the latest versions that have passed their tests and made available, and we assemble them together on our own tests, integration tests, to make sure that our Elk stack works the way we expect, and then we can kind of promote that, and we then make the changes to the production instance of the Elk stack, or different instances of the Elk stack. And so just to kind of wrap up, what we look to do then is to rationalize this kind of sprawl that we had before by saying, look, we're gonna apply these standards and packages and ways of thinking about things, and we can kind of apply them in place at first, right? So it's a progressive in an incremental approach do we say, let's take things that we have now and start packaging them up so that they're more standardized. And then we can think about how to integrate them together and maybe retire some. Maybe we could replace one that one team is using with something that another team has provided. So we can kind of over time start consolidating all of the things that we have. And so we do this again by standardizing how we integrate things that different teams and different people build. We're providing that scaffolding so that we consistently implement infrastructure as code in different parts of the organization and deliver it reliably. We want to encourage shift left governance. So rather than having to inspect every change to the code, have a security team or whatever look at the changes, we do the things like compliance as code and so on, so that whoever is working on the code can run tests and see, oh, I made a mistake and this isn't going to be compliant, and so I can fix it. And then we have an auditing trail and so on. And then we can support multiple implementations and even multiple clouds. So it's not that we necessarily need to have everybody using, for example, a single Kubernetes cluster, but we can be kind of clever about it to know that, okay, we actually, two different teams need to use Kubernetes clusters that are optimized in different ways for different purposes, but at least we're going to do it consistently. And if we're on multiple clouds, we can build things consistently so that it's easy to work across clouds and we can leverage some of our knowledge. And then again, we can have different team topologies. We don't have to say every teams need to be shaped in the same way, and all infrastructure and platform services need to be provided in the same way. Actually, they can be provided differently. So thanks very much. I don't know if we have time for questions and that sort of thing, but I'm happy to answer if we do.
Thank you, Kief. I think we have time for questions. Folks,
Okay.
do you have any questions for Kief?
No questions.